This video has been produced by the Sustainable Energy Society of Southern Africa Solar Water Heating Division. It consists of 4 parts. Part 1 is an overview of solar energy and solar water heating. Part 2 covers legislation, certification and standards, as well as an overview of domestic solar water heating system designs. Part 3 covers solar water heating configurations, systems, components, and collector orientation. Part 4 are 2 examples of solar water heating installations. One is a thermosiphon closed couple system, and one being a pumped direct system.
The Earth's climate has changed over the last century. The evidence is overwhelming, and the urgency of taking action becomes clearer with every new scientific study. Most of the global warming observed during the last 50 years can be attributed to human activities. The profound impact of rising temperatures in the Arctic provides a window into the future we may all experience. With continued warming, we can expect more extreme heat and drought, rising sea levels, and higher intensity tropical storms. Global warming is caused by emissions of carbon dioxide and other heat-trapping gases that are emitted primarily by the burning of fossil fuels and the clearing of forests. The answer to these problems does not lie in a single solution, but in diverse energy technologies. Solar water heating, as with other diverse energy technologies, can provide economic stability, a means to natural resource conservation and environment protection for future societies. In regards to economical solar water heating benefits, domestic electricity usage can save up to 70% on electrical geyser consumption depending on the system selected and how it is used. For example, a 100-litre solar water heater replaces 9 kilowatts of electricity per day, which results in impressive annual savings. Environmentally, solar water heating systems have less of an impact onto the environment in regards to water, coal, ash, SO2, NOx and CO2 usage.
SESSA have a code of conduct, and all members are to abide by this conduct. This will keep up a standard of installations and ultimately benefit everyone. SANS 10106 is the code of practice for the installation, maintenance and replacement of domestic solar water heating systems. SANS 10254 is the code for the installation, maintenance and replacement of fixed electrical hot water systems. SANS 10252 Part 1 is the code for water supply systems to buildings. And SANS 10400 is the building regulations. All installations will have the compliance with all of these standards. The solar collector absorbs the sun's energy and transfers it into the fluid inside the collector. A domestic solar water heating system comprises of a solar collector and pipes connected to a storage vessel. A collector can be a flat plate glazed collector or an evacuated tube collector. If the collector is lower than the storage tank, the system will not require a pump. If the collector is higher than the storage tank, the system will need a pump to force the heated fluid down to the tank. Thermosiphon happens when the heated fluid within the collector becomes less dense and rises up to the top of the collector. If the storage vessel is above the collector, the fluid will rise up and enter the tank, and as it does so, the colder fluid exits the tank and sinks down to the bottom of the collector. If